Hello class, today we're going to talk about section 2.6, which is all about ratios and proportion. At the end of today's lesson, you will be able to compare ratios to decide if they are equivalent and solve proportions. A ratio is two numbers that are being compared by division. You'll often see it written as a fraction, so 3 over 5. You may see it written out as a colon, so 3 to 5, or you may see it written out using the word 2. All three of those things mean the exact same thing, it's just a different notation. A proportion is an equation that says two ratios are equal to each other, so two equivalent fractions. For example, 3/5 is equal to 6/10. That's setting up a proportion. There are two equal ratios. A rate is a ratio that uses two different units. So, for example, I could say $3 per 5 cookies. And a unit rate is a ratio with two units where the denominator is 1. So if I said 60 cents per 1 cookie. So all of these are involving fractions. We're referring to them as ratios. First thing we want to talk about is equivalent ratios. The easiest way to figure out if ratios are equivalent is to find their reduced fractions. 2/5 is as reduced as it can get. 6/15, both of those can be divided by 3. If I divide the top by 3, I end up with 2, and the bottom by 3, I end up with 5. Next one, 18/40, both of those can be reduced by dividing by 2. I end up with 9/20. Next one, 12 and 35 are relatively prime. They can't be divided by the same number, so that fraction stays the same. The last one, 24 out of 60. Both of those can be divided by 12, and we end up with 2 out of 5. So our equivalent ratios are the ones that reduce to the same fraction. So 2/5, 6/15, and 24/60 are all equivalent ratios. Another good thing for us to know is when we set up proportions, we can use something called the cross product property. When you are doing the cross product property, it says that if you are multiplying along the diagonals, those two will be equivalent. So A times D would be equal to B times C. So you are multiplying across. So if we're looking at the example on the right, we know that those two are equal. To double check that, you are able to use the cross product property. So 2 times 10 is equal to 4 times 5. 20 is equal to 20. If I set it up, for example, with something that's not equal, so 2/5 we know is not equal to 1/3. If I checked the cross product on that, I would end up with 2 times 3 is equal to 5 times 1. 6 is not equal to 5, so these two are not actually equal, which is something that we know is true. So this cross product property allows us to decide if ratios are equivalent, and it will also help us solve if there are variables involved in our proportions. So, for example, we have A over 4 is equal to 9 over 12. We're going to start by using the cross products. So we get 12 times A, or 12A, is equal to 4 times 9. That gives us 12A is equal to 36. Finishing to solve that equation, we divide both sides by 12 and end up with an answer of A is equal to 3. Same thing works if you have a little bit more complex of an equation. You can still use cross product to solve. So I have 7 times 25 is equal to, in this case, we need to treat this top quantity as though it is in parentheses. It is one value. It is a sum together. So we're going to end up with 35 times that sum. This means that we need to use the distributive property. So we end up with an answer of 175 is equal to 35x plus 70. Continuing to solve using SAD-MEP, we're going to subtract 70 from both sides, which gives us 105 is equal to 35x. Finishing out the problem, we're going to divide both sides by 35, which gives us an answer of 3 is equal to x. So it's the same kind of idea, just a little bit longer because we have that sum instead of just a regular variable on the top. This would work if your variables are on the bottom, anywhere within your proportions. Go ahead and try solving this one on your own. You should have gotten a final answer of 20. If you have questions about this problem, please let me know when you get to class. The other time that ratios and proportions are very helpful is when you are setting up word problems. So it says the scale of the map of the Great Smoky Mountains National Park is 3 inches to 10 miles. The length of the Ramsey Cascades Trail is about 1 1/8 inch on the map. What is the actual length of the trail? So the first thing we need to do is set up a proportion. This is the first ratio that they give us. So 3 inches over 10 miles. It's going to be important that you keep those labels on there to make sure that you are putting your information in the correct spot. You could have set up your ratio as 10 miles over 3 inches. That would also be okay. You would just have to be careful how you set up the rest of the problem. So 3 inches over 10 miles. We want to then set that equal to. The other piece of information they give us is that the trail that we're looking at is 1 1/8 inch. Because inches are on top of our first ratio, we're going to want to put inches on top of our second ratio. We are looking for the value in real life. We don't know how many miles that is, so we're going to turn that into x. I'm going to go ahead and convert this into a decimal to make it a little bit easier for us to work with. So it's 1 1.25 inches. Then you're going to use that cross product property to solve. So we end up with 3x is equal to 10 times 1.125. Continuing to solve, we're going to simplify and get 3x is equal to 11.25. Dividing both sides by 3 gives us a final answer of x is equal to 3.75 miles, or you could say x is equal to 3 3/4 miles if you prefer to give the answer in fraction form. Go ahead and try this next word problem on your own. You should have gotten a final answer of 348 stores. One thing I would like to note about this problem is, as a general rule, there are a couple of places where you should be putting specific units within word problems. If they ever give you a money value, that should be going in the numerator of a problem. And if they ever give you a unit of time, that should be going in the denominator. That's why instead of doing 2 over 232, I moved the 2 down to the bottom. Now, how you set that up, as long as you set up the problem correctly, it shouldn't have made too much of a difference. But as a future rule, if you have an amount of time, it should be in the denominator. And if you have an amount of money, that should go into the numerator when setting up ratios and proportions. If you have questions about this or anything else in the lesson, please let me know when you get to class.